So this is lesson 2.6, Algebraic Proofs. And we're going to start off first with the definition of deductive reasoning, just again, which you have seen from section 2.4. And remember that that is the reasoning that goes from general to specific. So based on facts. Okay, and then a two-column proof is what we're going to take a look at next. It's also called a formal proof. So that definition is method of presenting of data or a proof or logical argument using a table or two columns, known as a two-column proof. So when it comes to two-column proofs, we've got kind of our statements on the left and then our reasonings on the right, and kind of step by step explaining how we get from one step to the other. So we have to make sure that we use reasons that are either properties, postulates, theorems, things that have already been kind of proven to be reasons, basically. We can't just make up our own. So for these here, addition property, basically if A equals B, then A plus C is equal to B plus C. Okay. If A equals B, then A minus C is equal to B minus C. So basically we can add the same thing to both sides, and that's called the addition property of equality. We can subtract. So we already actually have done all of these things before when we're solving problems. We just never had kind of a property to explain them. So then A times C is equal to B times C. Division property, if A equals B and C is not 0, then A divided by C is equal to B divided by C. Now the reflexive property is basically just saying that something is equal to itself. So A equals A by the reflexive property, like a reflection. If A equals B, then B equals A by the symmetric, as it looks pretty much symmetrical. AB, BA. The next one is what we call the transitive property. I always think of kind of like transit of a train. So if we have A equals B and B equals C, then since they're both equal to B, we can take the first part of our train and set it equal to the last part of our train because they're both equal to B. So then A equals C. They can connect the beginning and the end of our choo-choo train. Substitution is just like we've seen before, plugging something in for something else. So if A equals B, then A may be replaced by B in any equation. So that's substitution. Distributive, again, we've seen that before. So that is if we were to take, let's say, A times the quantity B plus C, and that equals A times B plus A times C. All right, so let's take a look at an algebraic proof. Algebraic proof is basically solving kind of an algebra problem, but using our reasons from up above that we've already kind of gone through as our reasons that we're going to list off to the side here. So our first step is going to be what we're trying to solve here. So 2 parenthesis 5 minus 3a minus 4 times quantity A plus 7 is equal to 92. And the reason is that it's given. So most of the time our first statement is going to be that it's given. So the next one if we're just thinking about what would we do next, we would distribute. So 10 minus 6a minus 4a minus 28 is equal to 92. And then our reason is either going to be, for this one, it's going to be that distributive property. Okay. Now what we're going to do is we want to combine like terms over here on the left. So negative 18 when we add up our numbers, negative 10a when we add up our variables, and that is going to be the addition property combining like terms or substitution. We're not adding. We're not adding to both sides of the equal sign. All we're doing is either combining like terms or substitution. Substituting if 10 and negative 28, we're replacing that with this. So you can either put substitution property / combine like terms, whichever one. Whoops. All right, so the next step is now to solve for a. So we're going to add 18. So when we add 18, that's the addition property. So you can either put the plus 18 or pretty much we put what that next level is, which is negative 10a is equal to 110, and then we say addition. We don't normally like show the work, if that makes sense, the steps within there. Addition property of equality. Now equality meaning we have an equal sign. So we might see property of congruence as well in our later lessons, and that's going to be using a congruent symbol, but since we're using an equal sign, it's equality. All right, next one is going to be dividing by negative 10. So a is, and you can show this step and then put division property and then put substitution or simplify as an additional step. You're just adding more steps. So with this step, you kind of want to, again, like we'd put addition property kind of goes more with what we just did up here, explaining every single step. And then we did simplifying that addition. So a is equal to negative 11. And so again, this would be division property. And then we end up kind of with our last step there, if again we want to explain every step. Substitution, because we're substituting, replacing this with negative 11, replacing this with just a, which is its equivalence. Okay, so basically making sure we explain each step. A lot of times you're going to see it in more this format where it's kind of giving you the boxes and having you fill in kind of each step a little bit more step-based and help you out here. So on our first one, what would we do if we're trying to, our objective is to get t alone. So our first step is to get rid of the 5. So we're going to end up with d minus 5 because we want to subtract 5 and 20t over here. So if we're subtracting, then we want to use our subtraction property. Or adding negative 5, you technically could use addition, but this one I would say more subtraction since you're subtracting your 5, subtraction property of equality. All right, so the next step, it looks like we need to get rid of our 20 by dividing. So d minus 5 over 20 is equal to t, and again that's the division property of equality. Now how can we write it with t over on this side? Well, remember, if we're going to move and make it t on this side, that's the symmetric. It's symmetrical. So symmetric property of equality. All right, so our next one, you can try it on your own or you can continue to watch along here. Our first is usually our given statement, what they're giving us. Our last is usually what we're trying to prove, and they'll usually tell us kind of both of those. So if the formula for area of trapezoid is this, then what would be the formula in terms of h? So we're trying to get what h equals, and then up here we're starting out with our area formula. So we're going to copy down what they're giving us and we're going to put given. Okay, because this is given to us. So now what we're going to do is we're going to do the multiplication property and we're going to multiply it to undo this 1/2. So take it times 2. 2a is equal to b1 plus b2 times h. So that is that multiplication property. Now it looks like we're dividing by b1 plus b2. So division property of equality. Okay, now it looks like we can just rewrite it with our h at the beginning and then 2a over b1 plus b2 by the symmetric property. Just kind of reversing those two. Kind of seeing the idea of how things flow. Let's take a look at another one. So this first part, again, it's given to us. We do not use prove ever as a reason. Prove doesn't mean anything. We are trying to prove it with all of these legitimate steps. Given is an okay reason because they're giving us this information, and that is an okay reason, but prove doesn't mean anything. What are you our goal is to prove it by showing each of these steps how we got from one step to the other. But starting out using given as like the start, that is okay. Of these are given to us, that these are, we got to start somewhere. Now, definition of congruent angles. If something is equal, then it is congruent. If something is congruent, then it is equal. So we're going to take this congruent stuff and we're going to change it to show that the measure of angle A is equal to the measure of angle B, because congruent means equal. And we're trying to prove things equal here in this one, not using our congruent symbols. So we kind of need to switch that to equals, but we need to say why. All right, now it looks like we're taking and we're replacing the measure of angle B with a 2MC. Well, that's given. B is equal to 2 times the measure of angle C. So it looks like we replaced this. That's how we're going from step 2 to step 3, is replacing. And when we replace something, that's called substitution. So you can use substitution. This one could actually also be the transitive property, because if you said the measure of angle A is equal to the measure of angle B, the measure of angle B is equal to this, then you could pick the beginning and the end. So either one, substitution or transitive property of equality would be sufficient there. All right, now it looks like substitution again, and we're going to replace the measure of angle C with 45. So 2 times 45, and that's the measure of angle A, is equal to. And then lastly, 2 times 45, well, all we're doing is substitution or simplify. We're substituting 90 for 2 times 45. All right, if you want to try this last one on your own, go for it. If not, I'll kind of pop the answer up there so you can take a look and kind of process through that one. All right, so here is that last one. The first part is given. And then we're going to go to the transitive property, taking the first and the last, going through definition of congruent segments, so changing it to equals. Then we're given that AB is 12, then we're going to substitute that in, and then we finally get RS is equal to 12.